Hey everyone, welcome to the inaugural episode of the Jetson AI Labs live stream. I'm Dusty from the Jetson team at NVIDIA, and here with me we have Dana from the Deep Learning Institute, along with Jim JetsonHacks Benson. Hey guys, thanks for joining us today.
Nice to be here.
So before we get started, just a couple of housekeeping items. If at any time you have comments or want to ask a question, feel free to enter that into the live chat. We'll see it here on our end and then can answer those questions for you guys. Likewise, we wanted to cover some new news before we have our guest, Jacopo Tani from ETH Zurich, who's head of the Duckietown organization, join us and talk about the latest in autonomous robotics in education. Before we did that, we just wanted to talk about some of the latest news in the Jetson world. So today or early tomorrow, we're going to have the latest Jetpack release come out, Jetpack 4.5. And have a bunch of new features and upgrades into it. So check out that on the forums and also the developer website. So Dana, do you have anything new going on in your area?
Well, we have the container for the DLI Getting Started with AI on Jetson Nano course, which originally was for the earlier Jetpack versions. As soon as the new Jetpack comes out, we'll have a new version posted up there. We also have actually a container that's in simplified Chinese up there now, and we'll be updating that as well. In addition, DLI, the Deep Learning Institute, which is what I represent, where we build the courses to bring to you, has a new website, which I'd like to let you know about. And you can find it at nvidia.com/DLI. That's the update.
Yeah, I'll share the link for that here in the live chat for anybody that's interested. So I guess a little background on me, Dana, and Jim. We all filmed a bunch of episodes that were launched along with the Jetson Nano 2 GB, the Jetson AI Fundamentals video series. And I did them on Hello AI World, and Dana did them on the DLI courses, and Jim did a bunch of awesome ones on the JetBot. He had some, I know people are a big fan of the music that you recorded, Jim, as part of that. So you got like a home studio there that you do all that with?
Well, I've been playing guitar a long time, so I have a lot more recording stuff than is reasonable. So the JetBot song, of course, it wrote itself pretty much. He's a happy little JetBot. So that was kind of, you have to have a song, you know, for any of these types of projects, you have to have a song. Yeah.
Well, your song was certainly the best out of all of those. And I think I see like an RC car and a shark in your background too. Do you do stuff with autonomous race cars as well?
Right. So right now we're kind of in a hiatus while the COVID thing's going on, but we're doing autonomous vehicles with F1/10, which is kind of 1/10 scale RC cars for autonomous driving. And we're coming out with a new version here, which uses the Jetson Xavier NX as its compute brain. And we have various configurations coming out, so it should be pretty interesting. It's gone through quite a bit of revisions as no one's been able to leave their homes.
Yeah, that's the thing with the JetBot. It's small, it's not very fast, it's fine for your living room. The Jet Racer, it wants room to speed, right?
Right,
And,
yeah.
I think I've seen a lot more people doing them in simulation during the COVID shutdown and such, but certainly everyone's chomping at the bit to get back out there on the circuit. But certainly that Xavier NX version sounds awesome.
Yeah, I've also been working on some of the preliminary carts for the Indianapolis Autonomous Challenge, which is kind of the 200-mile-an-hour version of autonomous racing. That's pretty wild stuff. So I've been using
I saw that on LinkedIn. I saw Joe Speed from AD Link, they do a lot of the ROS 2 middleware integration, and I guess they've been working on it. That like blew my mind how far that's come.
Yeah, I've been working on GPS for it, and I have a Velodyne LiDAR and all that kind of stuff. So I've been working on the Xavier ROS 2 stuff. We'll have to talk about that at some point.
Do you have one of the Velodyne pucks or one of the, I think they have even smaller ones now. Cool.
It's a Velodyne Puck Light, which I think that just means they have a lighter box to house the electronics, but it's interesting.
Yeah, that's awesome. So for others on the stream, I'm from Pittsburgh, and Uber and a bunch of the other self-driving car outfits are here in town, and I see a bunch of them driving out around the streets sometimes, and it's crazy how many of those Velodyne pucks they have all over the place. And
Oh yeah,
it's like they might take a normal sedan car, but then outfit it with like a crazy amount of sensors. So it seems like pretty cool. So I saw a question here in the chat about when will Jetpack 4.5 be released, and we covered it right when we started, but that will be released today or later tonight, depending on when it hits the content distribution network servers. So that's dropping imminently, and we hope to get all those containers updated again soon. Dana, I see a question just came through for you.
A second course on the Jetson Nano in DLI. Oh, not currently. There isn't one like that. But what you can do is take advantage of the courses that Dusty has set up, the AI World, and you can learn more about using Jetpack there, I think.
I think there's also the Deepstream DLI, right, Dana?
Yes,
does that work on the
out
Nano?
there. That we have a Deepstream DLI that was set up with previous Jetpacks, and we do have plans to containerize that and turn that into a DLI with the Jetpack 4.5. But
Okay,
it's not.
cool.
It's not. I can't give you a date on that yet.
Yeah, awesome. But I mean, generally, I mean, the person had asked about building production level tools. And generally, when folks graduate from like the Hello AI Worlds or the Nano DLI course and want to start processing multiple camera streams or doing advanced analytics and inferencing on them, generally they tend to navigate towards like the Deepstream type of SDK because it's like the best performance and handles like tons of streams simultaneously. And it also now supports Python as well. And it is all done through GStreamer, so it's based on an open source framework, actually. So anything else you guys want to chat about quick before we bring on our guest?
I want to hear about Duckietown.
All right, great. Well, today we have Jacopo Tani. He's a PhD and senior researcher from ETH Zurich, which is a highly renowned research university in computer vision and robotics. And he's also president and CEO of Duckietown. And he's done a lot of great things with the Jetson Nano on his robots and is here to talk about the latest massive online course that they're offering for free. So I'm going to add him to the stream now. Hey, Jacopo, thanks for joining us.
Hello, everybody. Thank you for inviting me. It's great to be here. Honored to be your first guest.
Yes. Well, thank you for agreeing and joining us. And we're really excited to talk more about Duckietown because it takes a lot of the concepts that we've covered in JetBot, but it's much more fully fleshed out in terms of like the full educational course and much more content in there. So without further ado, if you kind of want to introduce the viewers to like what Duckietown is, how it's different.
Sure, yes. So, I mean, Duckietown at the end of the day has a story that will go through it, but really it's an ecosystem designed to provide state-of-the-art autonomy, that's robotics and AI learning experiences that are accessible, engaging, and fun. So, I mean, I guess I can maybe show an introduction video just to show you guys how it all started.
Oh, sure.
Let me see if I get this working. Here you go.
Duckietown.
Gotta have music.
Duckietown.
That's a funky little sound. I like it.
So I take it that the goal is for it to like navigate across these dynamic city environments. It looks pretty advanced what's set up there.
Does everybody have the same Duckietown, or are you everybody gets a different one?
So actually, there is no fixed maps in Duckietown. You can make it as small and simple or huge and complex as you want. There's people around the world that did crazy setups. The whole architecture is modular, so you can just put things together, and as long as you respect the appearance specifications, that is some, let's say, formal rules we defined in order to create a city that the robots will recognize and will take cues from, then the sky is the imagination is the limit. So this actually is the video that came from the first edition of the course at MIT, when we created it to basically, let me stop this, to teach a class in robotics, and to the master students of the Computer Science and Artificial Intelligence Lab, CSIT. And really the objective was just to have something that wasn't the usual, you know, go to the blackboard, see the theory, get things to work, but to build from scratch, have a hands-on experience in building from scratch an autonomous mobility on demand system, ground up. Okay, so basically a fleet of Ubers, if you want, of actually self-driving Ubers. Okay, so imagine you have a fleet of autonomous taxis. How do you get it to work? How do you control them? How do you make them coordinate with each other? How do you make them just navigate the city? So we did this step by step with a big team of people. So let me actually see if I can show you guys one slide. So I'll keep it like this so that I can actually see you as well. This Duckietown platform was born to teach a class, and it was literally built by a huge team of students, of researchers, of professors that were led by Professor Liam Paul of the University of Montreal, and Dr. Andrea Scenzi of the now at the Swiss Federal Institute of Technology at ETH at Zurich as well. And literally, we started from nothing, and we made this thing that immediately attracted a lot of media attention. Maybe because of the Duckies. I mean, how did the Duckies make any sense with the self-driving cars at MIT, where everybody, you know, the nerds there studying, working, and all this color, all this nonsense nearly. But it attracted media attention, and that was a key factor that brought basically the platform to be adopted for different reasons, for research, for teaching, for just doing outreach in many other universities, either in the United States or internationally. But if you have a question, just interrupt me. Yeah? No,
I was just wondering how this, so this is for a university course, and other, there's other ways, I suppose, that are being used to teach robotics. This seems quite different. Do you want to kind of expand on what's so different about this method for teaching?
Yeah, so first there's an aspect of the fact that it's focused on self-driving cars, right? And that's a little bit because of the genesis. So it came from our lab of people that did lots of research on self-driving cars, and in particular on the control of fleet of self-driving cars. And you know, when you work on these things, so Dustin mentioned that he sees all these Ubers going around and the actual real self-driving cars operating in the cities, right? But imagine being a professor in a university, even at MIT, you know, where you're well-funded, well-connected. Typically what you do is you do your math, you come up with something new that you think is interesting, then you go to a computer, you do a simulation, you try things out, you see if they work. But if they work, does that really mean that you're done, that you can deploy it in the real world? Not really, right? You need to face the test of the real world. In robotics, everybody who does robotics knows that if it ain't tested, it's broken, right? So you have to really go there in the real world. And but how do you do it? I mean, how do you deploy a fleet of real self-driving cars in an actual city, which is, I mean, running experimental algorithms? You know what I mean? There's so many challenges that are, of course, economical, because there's a cost associated with these cars, and even at the non-technical level, right? You need to convince the decision makers that it's safe to send out these self-driving cars. So Duckietown was built to somehow sit in the middle between a simulation and the real world. Now, we kind of sometimes refer to it informally as an experimental simulator. So it's I think that it was well received and provided good it's a good tool for learning, because it really focuses on the problems, not on, we don't fall in love with the solutions. Like, we start from the problem. Like, what are the challenges that we need to face? We need to get a car to first move, then actually move in an autonomous way without breaking the rules of the road. And then maybe you have to do it while you add a little bit of complexity if there are other cars driving around you. Or maybe, well, what if there are obstacles? If there are duckies on the road, pedestrians, right? How do you avoid them? What if the city is a little bit more calm? So it's always trying to solve practical, real-world problems. And the way we do it, at least at the beginning, was literally collegial. Like, the students created, I think, together with the staff, of course, the mentors and everybody, this whole system. And we figured out the solutions together. And it was really hands-on. Nothing is hidden. So one cheesy thing we say about Duckietown is like, we bring you from a box of parts, pieces of metal or whatever, components, to a fleet of self-driving cars in only 3,147 steps without hiding anything. That's the key part, right? So you can literally delve as deep as your interest and your curiosity and your skills allow you to delve. So I don't know if that answers your question.
Yeah, we have some questions that are coming up on the line here. I hope I haven't missed any, but one of them is, what are the differences between JetBot and Duckiebot? And if I wanted to make my Duckiebot, are their designs open source?
So the difference between a JetBot and a Duckiebot, so first we have different the Duckiebot was iterated, the design throughout the years. Between 2016 and today, we had 4 generations. So I'll speak about the latest, NVIDIA Jetson powered Duckiebot. And I think that the differences are pretty much in the sensor suite. The Duckiebot has, of course, a camera in front, a front-facing camera with 160 degrees of field of view, has wheel encoders, has a time-of-flight sensor, has an IMU. It has LEDs from the actuation side of things. So it's always a differential drive robot. So it's always like 2 DC motors controlling the wheels, but it has this, the LEDs. So the LEDs are not just for show, but actually we use them for autonomous behaviors when it gets to actually getting the robots to talk to each other. So maybe there are better, more functional ways of doing it, but Duckiebots talk to each other, for example, to coordinate passage at an intersection. No? So how do you know who goes first without crashing? No? And they blink, and embedded in the frequency of the blinking, there is messages. So, I'm waiting for somebody else to go, or I'm reserving the intersection, or whatnot.
Like
right?
flashing your headlights at somebody.
Exactly, that was the spirit. And also, imagine if you do it for real. So you get to an intersection. What's the first thing you check? Well, is there a traffic light or not? No, is there a centralized, or is there a policeman, somebody that guides the traffic? So there is a centralized coordinator. You look at that. But if not, then you have to start inching maybe a little bit and starting the lights to see if to decide who goes first. So I think that apart from the presence of an extra actuator, it's actually 5 LEDs, maybe 4 in the new edition, and the extra sensors. There is a little screen on top that gives you some diagnostics, so some stuff like this. There's a button, just not to have to unplug the battery to turn it off. And we have a smart battery. So we had lots of headaches with batteries in the past. And although there are solutions, I mean, I think you all have experience of this. Power is always a tricky thing. So we designed our own battery from scratch, and it's a smart battery. So it actually delivers diagnostics to the Jetson board, to the computer on board. And so the robot knows when it's about to finish autonomy, when it's what's the situation, all sorts of other engineering data. And so, one key thing about the Duckietown thing is that it's not really just the robot. It's kind of a robotic ecosystem. So we have the Duckiebots, we have the drones, and we have the city. So the city is not just it's simple, it's toyish, like you have, these kind of like, not yoga mats, but like exercise mats that you put together. You basically have 4 or 5 atoms to build the city: the straight, the curve, 3-way intersection, 4-way intersection, or empty tile. And as long as you put them together in a way, of course, that it makes sense, that the roads connect to each other, you can build these big cities. But on top of that, you can put infrastructure. For example, traffic lights, or what we call watchtowers, which are basically robots without wheels. Okay, they have a computational unit, they have sensing, they have communication capabilities, and now you have this city with a decentralized network of smart infrastructure. So it's as if, I don't know, you put on every building a camera that looks down, and now the city itself knows where are the robots, what are they doing, and you can start playing with all sorts of interactions in this robotic ecosystem. And now, when somebody comes, of course, the aspect is all of course, you can do research, but there's always this pedagogical presence. We want to invite as many people as possible to engage in robotics and learn these cool things. And so, whether you maybe are more passionate about flying or driving, or maybe this weird robot that is a city that it doesn't really look like a robot, but it is, then you can attract different demographics.
So that's interesting. There's like an entire ecosystem. Could you describe the hardware for the drone a little bit? That was kind of
so
what
the drone
the vehicle is.
The drone is a project that was initiated and is currently shepherded by Professor Stephanie Telix of Brown University, and she did really an amazing job at creating from scratch this do-it-yourself, take always a box of parts and build your drone. And it's Raspberry Pi based, and the focus of that, let's say, curricula, that set of learning experiences, at the moment is more on the high school level. So the idea is we want to excite younger folks with flight, and then as they grow and get into the complexities of the system level issues, the software architectures, the deployment, and all these networks, all the stuff that always breaks down, and we hate, but for the part, they start from high school and with the drones, and then they get a little bit more at the university level in the fleet stuff. And we actually ran, was it 6 months last semester, pilots in many high schools in Rhode Island, and it was a very interesting experience, regardless of this, challenges of the pandemic and COVID. People didn't have access to.
Speaking of the challenges of maybe being remote, I understand you have a MOOC now. So this is something I guess maybe you wouldn't have to be at a university to participate in.
Absolutely.
Can you tell us about the MOOC and how to get started on that?
I think that we got lucky, if I may, in the sense that Duckietown was, because of a number of other activities that we run, namely the AI driving Olympics or the AI do. Can AI actually do anything? It's an embodied AI benchmarking international competition that we run biannually at ICRA and EURIPS, which are, let's say, premier conferences in robotics and machine learning, respectively. We created an infrastructure that allows not only, of course, to run hardware physical robot at home for anyone, standardized, nice, reproducible instructions, but we have the infrastructure to evaluate the performance of agents. That is kind of like the mind of the robot. Not anything the designer codes basically between the measurements of the sensors and the commands to the actuators. So that students at home can do whatever they want to do, exercises or just
a simulation. You have a simulator?
We have both a simulator and, of course, the real world setup. And anybody from home can ship this solution and gets evaluated both in the cloud. And we have these basically big Duckietowns in ETH Zurich, and now in a number of other universities, the University of Montreal, Toyota Technological Institute at Chicago, the University of St. Petersburg. There's more popping up as we speak. We are able to run on real hardware the solutions developed by people at home. So we got lucky in what sense? In the sense that we were already developing all this infrastructure to run our scientific competition, and then COVID hit, and now we had to teach students without having them access the big towns we have, for example, ETH. And so we found ourselves in a situation where this MOOC, which we had started planning, really fell in nicely. And yes, so we're going to be doing I would like to actually show a video, if I may. It's the first time that we show this video publicly, so a gift for you all. Let me see if I can.
While you're setting that up, Jacopo, there was a question a few minutes back.
Oh, sorry.
Dana mentioned the simulation, and the question was, what challenges do you see going from simulation to like real world robots?
I mean, no. So there are many issues. So many things that are interesting. So there's a saying, which is simulations are doomed to succeed, right? What does it mean? It means that when you use a simulator, you are kind of like the god of this world you created. You make the rules, you create the simulation. So you know what to expect. Sure, you can add noises and stuff, but you are even characterizing those noises. You are creating the world. You are in full control. The real world, no, you're not in full control. And you'll notice that the issues you end up having most frequently are things that were the simple things that you didn't think about. The light is of a different tone. It comes at a different angle. It reflects in different ways. The network has lags that you didn't think about. Whatever it is, like the wheel is a little bit wobbly, and so it messes up all the modeling and the predictions and the. So the real world has what are called technically nuisances, real problems actually. But it's all the disturbances that the environment that you cannot control bring in, and that's really a big challenge. The other thing is, there's all this thing about, of course, using machine learning based solutions to achieve autonomous behaviors, right? Which is something that is gaining preponderantly, let's say, a big part of the scene, and we all know that basically. What's the catch in machine learning? It's not like the panacea of all problems. No? You need to train stuff. You need to have data, and data is expensive. No, because it takes time to run the experiments. It takes, depending on whatever it is that you're trying to solve, it takes expensive maybe experimental setups. And so of course people say let's go in simulation. No, because simulation data is cheap, so you can run supercomputers overnight and gather as much data as you want. But then going back to the simulations are doomed to succeed, how do you know that the training you do in simulation actually transfers to the real world, right? Is it, or to what degree? Is it just about making it more photorealistic? Or maybe is it some adding physics, the friction of the wheels with whatever it is that makes a difference, right? So that's a whole I would say, active field of research, and the AI Driving Olympics actually addresses this, right? So what we do with this competition is we go to the public, we go to the scientific community, or pretty much whoever wants to participate, and we say, look, let's take some challenges, like drive the robot down the road without committing traffic infractions. We provide a baseline solution based on classical robotics, okay, approaches. So planning, estimation, and control fundamentally. Nice pipeline that makes sense to humans, right? Let's see if you can do better, right? And you can do whatever you want. Like you're free to provide your own solution. And so we've seen a number and then we benchmark it, right? So we have the basically infrastructure to do a scientific evaluation of how well these things do. And this allows us to try and start answering these questions, or at least, putting apples and apples and pears next to each other and see who does better in terms of keeping everything else constant. No? Because one challenge in robotics is that, to borrow a saying from biology, everything depends on everything. No? So of course it's not true, but in biology it is, not in robotics. But in robotics, it's a complex system. It's a bunch of subsystems. Everything has interactions with everything. Like if you untighten a screw, if a screw is a little bit loose, it might cause vibrations that then end up changing the model, and then your robot goes unstable. Okay, if maybe you change something in the controller, it might end up doing something that is so software, hardware. How do the different pieces of software talk to each other? These are let's say the software architecture, the deployment. No, all of these are things that play a significant role. So having the ability, thanks to the Duckietown platform and how we designed it, to be able just to substitute one piece, like one block, just the controller, just the localization, just the agent, just whatever it is, one piece of the whole complex pipeline, and keeping everything else exactly the same, that has value, because you change one thing at a time, then you can actually tell the effect that it has, even on a complex platform.
Let's see more ducks. I want to see more ducks.
I want to show you the MOOC trailer, because I really want to. It's like the first time we show it publicly, so I'm curious to see what our crowd says. So let me see how to do this.
This is what a JetBot looks like, by the way. Oh, Where's the ducks?
Robots are now capable of autonomous behaviors that were not possible only a few years ago. Self-driving cars are an application that will change our daily lives.
We are a team of professors and researchers who are passionate about robotics. Together, we will explore how self-driving cars actually work. Welcome to Self-Driving Cars with Duckietown.
This course will cover the theory, the algorithms and their implementation in simulation and on real-world robots. It will use methods of classical robotics as well as modern machine learning-based approaches.
We will solve tasks of increasing complexity, from having one Duckiebot move to having many drive safely in a city-like environment. We will use state-of-the-art software architectures based on ROS, Python, and Docker.
We will implement computer vision-based solutions for real-time localization, planning, and control. We will investigate various machine learning-based approaches, train neural networks using simulation and real-world data, and analyze their strengths and shortcomings in practice.
Join self-driving cars with Duckietown, the first robot autonomy MOOC with hands-on learning.
This is really great. So you sign up for the MOOC and you get to do all this stuff in simulation, and then it's up to you if you want to then move it into hardware, which, as you've explained, that's where we really need to get it going.
The MOOC,
so what do they need to do to get started to really get
For
the
its
most out of the
unwatched
MOOC?
masses? What does MOOC stand for?
Massive open online course. So I always mess up the double O's if it's open online or online open, but I think the message is the same. So one of the key mission, the key let's say objectives of the whole Duckietown project is really that to reach the broadest possible audience, right? So the MOOC is free in the sense you can sign up, enroll now, it's online, just go there, click the big green button, or I think it's red, and you can do everything. You can go through the course in simulation, in the simulation track. Now, if you want, and it's optional, you can get a robot, an NVIDIA Jetson Nano 2 GB powered Duckiebot, the 4th generation of its name. And at that point, you can experience the same things you do in simulation on the robot. And of course, there's going to be differences. There's going to be challenges. Everything is going to break down, and then we'll have to fix it and all of that. That's where the learning, I believe, really happens, because robotics cannot be learned without having a real robot. It sounds like trivial to say, but the challenges induced by the real world are really important to explore if one wants to really gain the competence needed to develop, real skills that you can transfer then to other, maybe in your job or in other projects, right? This MOOC, while it is an introductory level course, we don't expect anybody to have prior experience in Duckietown. It still requires people to have a little bit of at least coding experience, like at least in some language. Then we will use Python, but we can't cater to people that never coded before, right? And it's targeted to mainly university level students and professionals maybe that want to refreshen their knowledge about this new, cool, exciting technologies that are coming up.
So in that video, you mentioned that you're doing both classical robotics and a bunch of different machine learning networks and models.
So the idea...
Can you speak to what algorithms are we going to learn and what type of models are we going to train?
So the whole I think real added value for us in introducing the Jetson hardware in the robot was to enable running machine learning algorithms locally, like this on the robot, not on a computer that then ships the data to the robot back and forth, right? And so what we can do in the MOOC and in Duckietown in general, the MOOC is going to be a little excerpt of the Duckietown, let's say, educational materials. If anybody of you goes on docs, the duckietown.org or the documents, you can see all our stuff there basically. And we will be picking different, let's say, exercises or learning experiences and run them directly on the robot. So in terms of actual, let's say, computer vision algorithms, autonomy pipeline, we have what, say, some baseline solutions. So the classical robotics would mean anything that has to, something that is structured, typically how human organizations are structured. Now you have the response, like the expert on controls, the expert on planning, the expert on
like a Huff transform line following algorithm or something. To
exactly. So you do something. Yeah, first you have to do some pre-processing on the images. You rectify them. Maybe do some color correction, because when especially the previous editions of the robots, vision is the main thing. So you change a little bit the colors. You change the one of these nuisances, the lighting in the room. Lots of things change. First you normalize the let's say the color. You color correct the image and you rectify it. And you identify edges. Then you use a notion of what is the mathematical, basically the model of the robot, together with the geometry of the city. I remember at the beginning I said the cities are formally specified, right? And you can use this together with the camera calibration data to get a 3D representation of where the robot thinks he is in the map. And then using this, the pose basically of the robot in the road, then you can feed the information to the controller together with some notion of what is your plan and what is your objective. You want to just go straight or whatever it is you want to do. And this closes the loop. No, so you get the robot to at least drive autonomously. Of course, the situation can become very easily much more complicated as soon as you introduce different states of control. Now, so say you want to stop at an intersection, for example. This is something we're not going to be covering in the MOOC. The MOOC will stop at the the following part. But now, all of a sudden, the robot needs to switch mode of thinking. Well, do I need to check for the traffic light, as we were saying before? Do I need to check for other robots? What kind of intersection is it? Where do I need to go? What are even the options, right? There's a whole new level of complexity, even without considering multiple robots. In the machine learning approach, now we see all these challenges that we have. The one I think unique thing about, I don't know if it's unique, but one cool thing about Duckietown is that we are solution agnostic. Like, it doesn't really matter what solution you choose to solve the problem, right? So you can use pretty much any machine learning based approach. You can use reinforcement learning, imitation learning, whatever it is, and then we can easily compare how things go. So in the MOOC, we will give a taste of everything. The MOOC is an introductory course. It's going to be not comparable to a full-fledged university course, of course, because it's a different medium of communication, and we have to, communicate in a different way. But we will touch upon different solutions. Sorry?
I'm sorry. How long does it take to work through the course to get kind of the...
Yeah, it's going to be... So let's put it like this. I think it's kind of like a war. When you start, you don't know when you're finished. Not so... Or let me rephrase this. It's the robotics always presents more challenges than you expect at the beginning. So we provide a nominal, let's say, target of 4 to 6 hours a week for maybe 9 to 10 weeks. Okay.
Oh, okay.
In our experience, and we warn our students, we nearly threaten our students when they start the courses. We tell them, hey, like, if you think you're busy because you have many other courses or whatnot, like, don't take Duckietown, because you really will have to spend time getting the robot to work in the real world. And it typically takes way more time than it's expected, and it depends on your skill level and on the patience and the goodwill and all these things, right? So I don't know if that answers your question, but
for a few months. So it's a few month type.
Yes, it's going to be a month and a half too. Yes.
Yeah.
I saw somebody before asking a question about if we plan a MOOC on the drone as well. It's actually interesting. Yes, we are. I cannot provide a timeline at the moment, but we are going to provide us in the longer run. We're going to provide a sequence of courses that one can do with in the Duckietown ecosystem. So there are going to be drones. There's going to be the link following one, which is the one we're starting now. And then slowly we're going to be increasing the complexity up to getting to control a fleet of self-driving cars. That is the autonomous, the original, objective of why the Duckietown platform was created. This autonomous mobility on demand problem, which is really challenging and exciting. Somebody else asked. Go ahead.
Oh yeah, I was going to say there was a couple of questions from before we played the video that I want to make sure we got to about people that are interested in this, and it was. Somebody, they were living in an apartment and they were wondering how much space do they need to set up the Duckiecity?
So I mentioned before that we have these appearance specifications. What does it mean? It means that you kind of have to respect some rules. The lanes have to be a certain width, and the colors of the whatever, the tapes have to be a certain thing. So the smallest possible city you can make is, in Duckietown, we use tiles as units. Now, forget about meters, feet, whatever, it's all in tiles. So it's a 3x3 tiles. It's like the smallest possible loop, basically, with an empty tile. That's roughly 2x2 meters. If I'm not mistaken, it's roughly 40 square feet-ish. And the MOOC track that we provide in the MOOC kit. So when you join the MOOC, if you decide to take the hardware, you get a robot, a Jetson powered Duckiebot, and you get a track, which is a little bit bigger than a 3x3. If I'm not mistaken, it's like a 6x3 or something like that. So we allow for a few intersections. Although we might not use them at the beginning in the course, we provide them so that the people who are particularly interested and want to push the challenge a little bit forward, they already have the stuff to do it. No, again, we're going to be making in the future other MOOCs, and we don't want people to have to retake everything again. Like they already have the city that. So 2x2 meters is the smallest possible. It's enough to join the MOOC and do everything you want to do.
Is it like quick to set them up? Can I like set it up in my living room and then when I'm done for the night?
Yeah, it's like I don't know. Sometimes you go to the gym, you find those like like foam mats where you put the weights on to damage the floor. That's the stuff. Like it's a puzzle. It's like it's kids level. It's toddler safe stuff. You have to do at the beginning a little bit of do-it-yourself like assembly. You have to cut the tapes, put it in, and put the traffic signs in the right places and stuff. And we left it this way because it's part of the learning experience. So the idea, I think this is another characteristic of Duckietown, is that we try to pass on the message that it's not just about the robot. It's about the robot and their interaction with the environment. So if you build the environment, you understand what are the key features, what are the things that robots need to see in the environment in order to operate. No? Going forward, there is going to be, in fact, this whole challenge of shall we change the infrastructure in the cities and the real world, to make it easier for self-driving cars to come about or not. So Duckietown provides a little bit of this as well. I'm seeing a ton of questions, and some are really
hop right in there, yeah.
So let me see. I think I answered.
So one question was, is there a difference between the JetBot and the Duckietown robot? We kind of covered that. The answer is yes. The basic differences, as I understand it, are there's wheel encoders on the Duckiebot, and there's some LEDs and an IMU. That's the.
Does it have ultrasonic also, Jacopo?
No, just a time of flight sensor in the front.
Oh, TF. Okay, cool. There was a question, I guess somebody already has a Nano or a Nano 2 GB, and they were wondering, does the Duckiebot support the Nano 2 GB or the 4 GB, or do you need a particular version?
So to be clear, the Duckiebot only uses the 2 GB version. So if you want to use the 4 GB version of the Jetson Nano because you already have it at home, I mean, of course, it's technically possible, but we'll see, in the sense that at the moment, we do not support the 4 GB thing because we'll have to base it off to different images and it doesn't play well with the Duckietown infrastructure. We need to focus on one solution that works well. We wish we could just do
the old image
for both, right?
If I can do anything to help you there, I'd be happy.
Absolutely. Maybe we
my guess was it was like you had a USB-C power supply, but if it's a matter of rebuilding the image, I can help you with that.
We can talk about that, but I mean, cool. Eventually, yes. The reason we use the 2 GB version is because, again, there's this concept of accessibility. We want Duckietown to be easy to get, as affordable as possible, and so the price point made a difference, right? That's the
Here was a good question from somebody asking like about the prerequisites and what can they do to prepare to take the course, like learning Python or Rust, or what do you recommend?
Get a dual boot installation with Ubuntu on your computer if you never did that before. That's a great piece of
to make sure you have Linux, right?
Yeah. Yes. We run everything off Ubuntu 20 or 4, whatever it is. Make sure you have a network that you have admin powers on. This is in our experience, in the experience of the Duckietown community, 99% of the times you have issues, it's the network. Networks are always the thing that break, okay? So make sure you have admin powers on your network, because there are some weird parameters you need to be able to change in order.
If you're in like in your dorm or something, maybe just get your own Wi-Fi router or something private at work. Okay.
And then, I mean, we have some prerequisites for the courses. So we ask people who join to be comfortable a little bit with physics and math, linear algebra. Like, you need to know what a differential equation is. We're not going to be, you know, re-going through ODEs to explain maybe, I don't know, the unicycle model or stuff like that, right? So a little bit of math, a little bit of physics, some programming experience. So we will give some tutorials at the beginning, maybe with ROS, Docker, you know. We're not going to teach you how to use Python like you should.
It's Python, right?
It's Python, yes. Python is going to be
So take some Python tutorials, or
yes. Okay. Someday we're going to have Python with Duckietown MOOC, but not yet.
Do you use OpenCV? Is that helpful if they learn that?
Yes, we do use OpenCV.
Okay. What do you use for your machine learning training? Is it like PyTorch or TensorFlow?
PyTorch.
PyTorch. Cool.
Yes. So we're going to keep this as a surprise for the MOOC. We'll get people to join and discover it as we go. Yes, but PyTorch is going to be.
Okay.
We'll try to support TensorFlow,
though,
but we're not sure that we're going to be able to do that.
The Jetson AI Fundamentals uses PyTorch too. So.
Yeah, PyTorch, it runs really well on the Jetson for like training in particular. So. Great choice. I don't know, Jacopo, did you have any in particular you wanted to answer here next?
I'm scrolling. I see lots of people that are tagging Richard Love. I think there was a question.
Your teammate from Europe. Thanks, Richard, for the help.
I think somebody asked before about a upcoming announcements for Duckietown. We will make the announcements at the right time. But yes, there's something really cool that we're going to announce shortly, and it's going to be a great thing that falls within, let's say, the NVIDIA ecosystem, and it's going to be fun. I don't want to make names now, though.
Cool. Well, I mean, sharing the video, premiering the video here was awesome too. So a question: if they already have the Duckietown robot or get the robot and the Nano and everything, is there like an enrollment fee for the course, or is it free from there?
So if somebody I saw posted already, maybe it was you, Dustin, the link to the course. If you just go on edX, you can already find the MOOC. It's called the Self-Driving Cars with Duckietown, and it's free to enroll in. I mean, if you want, you can get a certification. I think it's $50 USD. If you want, you can get the hardware.
There's a price for the certificate. Can you complete it and the certificate without building the robot?
Yes.
Okay, so you could,
if
you don't have enough money to actually build the hardware.
Yeah. So you can like do it all in simulator.
Yes.
On your Ubuntu PC or laptop, essentially. Oh, that's awesome.
I see. Jacopo, any idea on upcoming upgrades for the Jetson Nano? We are rolling out now the first edition. I will take a step at a time before putting upgrades, but I believe that so the way we're set up is in such a way that we will follow NVIDIA's lead on this. As soon as if there are upgraded versions of the Jetson Nano, probably we'll be able to include them in that.
Yeah, as far as the Jetson roadmap goes in particular, if you just Google Jetson roadmap, we have a page on there with the hardware roadmap. So the next, big Tegra SoC that's coming out is codename Orin, and the timeline for that is like 2022-ish, later in 2022. And so we have a chart there that shows that, and if you Google it, you can find some awesome presentations from Hot Chips. It's like an incredibly exciting SoC. It's the upgrade to the Xavier SoC. So we're really excited to get the silicon for that and do all that awesome work on it, and hopefully we'll have some awesome Jetsons to bring for that.
I see a couple more questions, if I may continue answering them. So somebody asks, how fast is the robot? I assume they're asking the Duckiebot. So not really fast. I think it's around 0.03 meters per second. I mean, we cap the speed software-wise in order to avoid the slipping of the wheels, because if the wheels start slipping, then the mathematical models we use to predict the pose of the robot in the future, so the odometry and all the, let's say, localization algorithms that we run, we have like a recursive Bayesian filter running on the robot, and they will go out of whack. So to keep it easy at the beginning, to understand, to learn, we slow it down to the point where it doesn't slip. But it's just a parameter to change, and it goes much faster. But it's even more difficult to handle then. So so Duckietown is not about racing. It's about precision driving. It's about being good drivers in a city and being respectful of other inhabitants of the city, which are the ducky rubber duck pedestrians, as well, of course, as the other robots going around, right?
So the duckies are the pedestrians? So.
Yes. So the whole spirit of Duckietown is that you have a city of rubber ducks, and the mayor of Duckietown is deploying autonomous mobility on demand system for rubber ducks. So the robot cars go around, pick ducks, and bring them to places. I think that there is this idea of the ducky that is something we really brought it in to try to break the preconception about robotics being something that is appealing only to nerds fundamentally. So when people think about robotics, they think about something that is fast, that is powerful, that is precise, that is dangerous. Like the big robotic arms in the auto industry or things like this. But really, Duckietown is designed on purpose to be the opposite, to be imprecise, to be slow, to be definitely not dangerous, and not to be powerful, But at the same time, it's as complicated and as real, as challenging, as scientific as the real robots, right? And the ducky is kind of the symbol of this. Now, it's this cute, to the best of our knowledge, is a universally accepted symbol that is not offensive in any, agriculture or whatnot. Yeah. And it's kind of, the symbol of this. So
if you have the need for speed, those RC race cars, I think, Jim, they can go up to like 40 miles per hour. Like the Nitro one's much faster, but
they go scary fast. I think Chris Anderson, who is the head of DIY Robocars, is on the chat here. So
yeah, I saw Chris. Thanks for joining us, Chris.
Somebody asked about what are the sensors used in Duckietown, in the Duckietown bot. So I think they're referring to the city. Please correct me if I'm wrong. So the cool thing is that everything is modular, both at software and at hardware level in Duckietown. So literally the hardware used for the city is the same hardware used for the robots. I mean, traffic lights are Duckiebots without wheels. They have the same hardware. And watchtowers are traffic lights without LEDs. So they have the same hardware, but without the LEDs, right? And we do still use Raspberry Pis for the city side of things because we don't need GPUs. It would just increase the price, basically.
What kind of camera is on the Duckietown, the Duckiebot? Because we're having a lot of questions about cameras generally.
It's the, I don't remember now, IMX 216, I think. The image sensor.
IMX 219.
Yes.
Probably. Yeah, that's like the Raspberry Pi camera module.
It's widely
supported.
Standard.
Yeah. If you want a MIPI CSI camera, that's probably one to go with. And you can either get the Raspberry Pi. I'm speaking for general Jetson folks now that just didn't get the Duckiebot kit. The IMX 219s are good, and there's a bunch of different ones that you can get, and they all work with the Jetson because the driver's built in. And I mean, Jim, Dana, and I, as part of our AI fundamentals course, we also use a lot like these Logitech C920 and C270.
C270 is the inexpensive one. I would say for the DLI course, really the USB camera is the best one. And if you have a USB webcam, you might just try it. And the reason we kind of prefer that to the CSI camera for that course is it's so much easier to set it up so you can do your thumbs or your faces easier than the CSI camera.
If you're just working on like your workbench or whatever, the USB cameras are nice because they have a long cord and you can put it on a tripod, and they're H.264 encoded, so you can get full 1080p or whatnot. But if you're doing like a little robot like the JetBot or the Duckiebot, a lot of times folks tend to go for the CSI camera modules because they're much smaller. And we have a wiki on eLinux that has like a bunch of others, but there's a bunch of companies that have made some really cool ones too, if you're like really into 4K. Or we also recently added support for the Raspberry Pi HQ camera, which is like, I think it's IMX477, and it supports a C or CS mount lens. So if you wanted to make like an actual camera with a real lens on it, you can do that, and we have the driver for that now.
I don't know if you ever tried it, but we had some projects back in maybe last year. We put event-based cameras on the Duckiebot. Of course, it's a super expensive piece of equipment, so it's only for research purposes. But that's something. I'm waiting for low-cost, event-based cameras to come out, so we can explore the whole new beautiful level of vision.
So there's more questions.
I could take an hour about it.
Yeah, the camera. So this is the V2 version for the Raspberry Pi,
yes,
right?
The V2. The V1, which is I think is like an OV5647 sensor. That sensor is EOL. So there's no driver support in it for that. So get the V2, which is IMX219, or in general, any of the other IMX219 derivative cameras work as well.
What's the HQ camera? It says only on the 2 GB?
There's also a patch for it for the 4 GB. So the 2 GB, Nano 2 GB, which came out after the HQ camera, it can work without removing one of the resistors on the camera. It's like a power line select sensor or something on that HQ camera. And so there's no resistor modification needed. But if you wanted to use it on a Nano 4 GB or Xavier NX, there are the drivers available for them. And you just have to like either remove the resistor or use a interposer board that you can get from Adafruit, which essentially disables the resistor through the interposer without you having to modify the camera itself. I know that sounds like a bit complex, but essentially there was something with the CSI design that was a little funky with that. But big shout out to Ridge Run, because they kind of wrote the driver initially for that and pioneered this whole resistor modification thing to get it all working on the Nano 4 GB and the NX, and then work with us to get that driver into Jetpack. So great work on that, guys, and really appreciate that.
I see a couple more questions here. One about how are you able to see the footage from the Duckiebot? You can either stream it if you really want to just see what the Duckiebot is seeing, or you can record raw specs and then play them over later. Basically, if you want to do even some analysis.
For the streaming, is it like RTP or is an RTSP server? How does it stream the video?
I mean, I'm not sure exactly now, but
I guess a better question is like, can you go through your web browser? How do you control the thing?
We have different user interfaces. You can do all terminal based, or we have a specific dashboard that we created. So it's all browser based, and you can do all sorts of fancy stuff. Actually, you can use that to do not only the Duckiebot, but a number. You can even control a Duckietown, an auto lab, like a Robotarian full-fledged thing. There's lots of, and we're going to be adding lots of very cool features going forward.
I think in your video earlier, I saw RViz being used.
Yes, definitely. So that is part. We can run that in the context of the dashboard as well, or you can run it, of course, on your.
Cool. Oh, interesting. I missed that. So it's all ROS based.
Yes. Oh, I didn't mention. Yeah. So it's the software architecture has basically. So we have Ubuntu at the bottom. We have something we call the Duckietown shell, which is kind of like a way to make it a little bit easier to call the various bits and pieces. We have everything Dockerized, and then we have ROS to transport messages between the various bits and pieces of the architecture, and then we use Python inside the ROS.
And which ROS? Which ROS is it?
One, not the
is it like melodic or noetic or
the latest one?
Okay, it's either melodic or noetic. But I guess have you looked at doing ROS 2 at all, or
yes, we have already looked into all of that. It's something that is definitely on the roadmap of Duckietown.
Okay.
We didn't flip the switch just because there's so many things going on, and
there is a lot.
You want to have a stable.
Yeah, I migrated my nodes and containers a while back to ROS 2, and it was for myself, like a non-production user. There's a lot of minute changes and like all of the function names and stuff, but it all like worked just the same. And so on GitHub, we have all the containers now. And
Actually,
Node
Rust
does
2 would
cool
allow
code.
us to do some cool things in the Robotarium because.
What about that? What about that last question here? Does it quack when it drives? I think we need to know that.
You know, that's you know, it's level 2 Duckietown thing, but you have to go through the MOOC first.
Student
we actually
special
do
project.
have designed the Duckiebot, and this is I mean, somebody will hold it against me at some point, but now I'll say it. We did design the Duckiebot with speakers and microphones. So eventually, that was the reason. Like, we even designed autonomous duckies. Okay, the duckies like they actually move and squeak, to have like moving pedestrians. But this is
and you're just now telling us this. This is
but this is gonna come in the future releases. Now one step at a time. It's we did not include microphone and speakers in the base edition because it's just too much stuff. We don't have anything to do.
Awesome. Well, since we're at the top of the hour, Jacopo, maybe if you want to pick one last question to take, and we'll wrap it up.
I saw somebody asking me a very important question, which was, I can't find it now, but the essence of it, if I'm not mistaken, was if we have already similar, we have the Jetson Nano, we have the same bits and pieces, can we put together our own robot and use the Duckietown? So the answer is yes and no, in the sense that with the sufficient amount of work, yes, of course. But we cannot, since we didn't test it, we cannot guarantee it's going to work. And due to human constraints, we won't be able to support multiple configurations, because otherwise it becomes too much entropy, too many different configurations. We won't. I think it's not like we are lazy or we don't want to do it. We believe it drives away from the key idea that Duckietown is trying to bring in the whole robotics education, let's say, scenario panorama, is that autonomy, that is the modern robotics, is about the deployment of software architecture on the hardware. It's not about the hardware itself. So the hardware is kind of like a solve problems. Many hardware things, lots of cool stuff out there, like plenty of coding and hardware, nice stuff. But if you want to go to the next level and do really the fancy new modern stuff, we want to all agree and standardize the hardware so that it reduces the entropy, it reduces the sources of errors. Remember I said like everything depends on everything. At least let's take the hardware out of the picture. So the short answer is probably yes, it should, in theory, yes. But until it's tested, and we did not test it, I will say no, it's broken, just to go with the wisdom of robotics.
Very good. Well, thank you so much, Jacopo. This was a great session, and really
thank you very much for inviting me.
Joining us.
Yeah. I think this is the best show we've ever had.
I think so too.
It must be because of the tie, right?
Yes. All right. Well, thanks everybody who joined us on the stream. Really appreciate it. If we didn't get to your question, please just post it to the forums or reach out to us. We're all on GitHub and LinkedIn, or Jim as JetsonHacks.com. So with that, stick around and we'll see you next time. Thanks, everyone.